In this video, we're just going to continue on with our notes on page 3. In the last video, we looked at how to find the derivative using some properties and the power rule, quotient rule, and the product rule. Now we're going to continue on with that and use that information that we learned in the last video to find things like the equation of the tangent line or horizontal tangents. We're going to use the same properties we've learned before of how to do these questions. Before, we just had to use the definition of the derivative by using the limit definition. But instead of using the limit definition now, we can use those properties we've learned in the other video to find what the slope would be at that specific point or at a specific slope. So let's look at example 4. We're going to find the equation of the tangent line when we're given our y is equal to 2x e to the x at 0, 0. The first thing you want to do is find y prime. We want to find y prime because this will give us the equation for all the slopes possible for our graph y. And once we have that, we can insert our specific point of 0, 0 into our slope formula or our slope equation to find what the slope is going to be. So we're going to find y prime first. And if we take a look at this, we have f of x and g of x, two different functions multiplying together. We're going to use our product rule. So this can be our f of x, and the e to the x can be our g of x. According to our product rule, we're going to take the derivative of f of x. That's just going to be 2. And then we'll leave g of x alone, plus the derivative of g of x, which is e to the x, multiplied by f of x, which is 2x. Now let's evaluate this at 0, 0 to find the slope. So I'm going to plug in x equals 0 into our y prime equation. We're just going to be left with 2 here. So 2 times e to the 0 is 1, and then this whole second term goes to 0. So last, we're going to put our equation together, which takes on this format of y2 minus y1 is equal to your slope times x2 minus x1. Our y1 and x1 are coming from our point 0, 0, and m can be replaced by our slope of 2. So this would be y is equal to 2 times x, and that's our final answer. Example 5 is very similar, but in this case, instead of given a point, we're given another line, and it has to be parallel to this line. In order for our curve to be parallel to that line, we need to make sure they have the same slope. So let's rearrange this equation here into the form of y equals mx plus b to find what the slope would be. So I'm just going to move the 2 to the other side and the negative 2y to the other side. And then divide both sides by the 2. And this is the equation that we get. The 1/2 over here is in front of your x. This is your m value, which is also your slope. So we want m to be 1/2. Okay, so the first thing you do is rearrange that equation so you can find what your slope would be. We want to find equations of the tangent lines that are parallel to this. So your tangent lines will have this slope. And the curve that's given to us is y equals x minus 1 over x plus 1. We need to find what our values are going to be when this is equal to 1/2. So let's take the derivative to find our slope equation for this curve. We're going to use our quotient law for that because we have a function divided by a function. Our numerator can be f of x and our denominator can be g of x. So we'll take f prime of x, which is just 1, multiplied by g of x minus the derivative of g of x, which is 1, multiplied by f of x, all over g of x squared. That's our quotient law. Let's simplify this a little bit more. So this is equivalent to saying 2 over x plus 1 squared. This is the equation of all your slopes with this curve that's given to us. We need this to equal to half. And now we need to solve for those x values that would give us that. So I'm going to cross multiply and divide here to solve for our x. Then I'm going to expand. That one side, that's x plus 1 times x plus 1. And then I'm going to move this 4 to the other side and then have that our right hand side 0. And we want to solve for x, so that's why we want to move everything to one side so we can factor in order to solve for x value. And once we factor, we should get x plus 3, x minus 1. So then your x values are negative 3 and 1. We have the x values, we also need the y values. So we're going to plug this back into our original equation. Let's plug in negative 3 first. And you're going to get negative 4 over 2. Negative 4 over negative 2, which is just 2. So that means we have the point negative 3, 2. And then you can solve for the other one, which is going to be 1, 0. Again, you can just plug the 1 back into the original equation because 1 minus 1 is 0. You already have 0 in the denominator, so then overall your y value will be 0. Then lastly, that was a bit squishy here, we're going to find our two equations. So remember your slope is going to be a half, but now you finally have the x and y values to plug it into the standard form of an equation. So the first one will be y minus 2 is equal to a half times x plus 3, that's one equation. The other equation is going to use the 1, 0 point, so y minus 0, or just y, is equal to a half times x minus 1. And those are your two equations, and that's it. The last example here, we're going to look for x values for our graph f of x whenever they have a horizontal tangent. This also means that the slope will be 0. So what we need to do is find the equation of all the slopes, which is f prime of x, and then we're going to set it to 0 to find those x values. So we're going to find f prime of x first. And to find f prime of x, we have term by term here, so we can just take the derivative of each term individually. We're going to use our power rule for all three terms. So for our first term, the power rule states that we're going to put this 3 back to the front and multiply it with a third, which is just 1, and then minus 1 from our exponent, which is going to be 2. And the next one, same thing, put the 2 down as a coefficient in the front, and then minus 1 from the exponent. Then lastly, we're just going to be left with negative 8. The derivative of x is just 1. So that is our f prime of x. Now we want to set this equal to 0 because the slope has to be 0. Now we're going to factor to solve for our x value. This will be x minus 4, x plus 2. So then x is equal to 4 and negative 2. So that's the x values that will have a horizontal tangent for our graph of f. Now go ahead and do that try it yourself question right now, and then when you're ready you can take a look at the solution. So for this try it yourself, you want to find y prime, and before you begin, you could combine your x values together by using the property that when you have the same base, you're going to add the exponents. So this would be 1 plus a half to get x to the power 3 over 2. If you end up using the product rule, that's fine too. You're going to get the similar answer. Might be longer, but it'll be a similar answer. So this is your y prime, and we're given the point 4, 8. So we're going to evaluate this at x equals 4. So you're going to take the slope equation you found, your y prime, plug in x equals 4 to that to find your slope at that point. Once you have the slope, you also have the point already, your x and y value, to plug it into the equation. And that would be your final answer. And that's it.